Thank you very much for coming tonight. This is part one of a two-part program. So here tonight we're going to be focusing on the initial steps you might take to improve the efficiency of your home, both energy and water. Really what we're calling discovering your home's potential. And you're going to hear from several experts about different types of energy audits that we're now offering through a new program with Fort Collins Utilities, the Home Efficiency Program. So what are we trying to look at in a home audit, an efficiency audit? There's really three components to it. So there's your physical house itself, the walls, the windows, the insulation, when was it built, how big it is, things like that. That's one important component. The second is what's inside your house. You know, we see houses out there, some people have 3 televisions and DVRs, a refrigerator and a freezer, and multiple personal computers and things like that. And others just want to cozy up with a CFL and read a book. So that's a second important factor. And the third is you. You're a part of your house, how you operate your house, what kinds of temperatures you like. Do you like it 68 degrees? Do you like it 72? Do you like the windows open in the summertime? Do you like to come home and see the lights on? Those are all factors that go into it as well, and things that an audit needs to account for in really getting a picture of how you use electricity, use water, use natural gas, how comfortable your home is, and in some cases, health and safety issues as well come into play. So we're going to kind of weave through a medical analogy as well tonight. So starting with that, the simplest one might be, you know, I'm feeling pretty good, but I'm part of my work's wellness program. So I might do a wellness quiz or a health quiz, and in that you're going to go through and you're going to answer some questions about how old you are and how tall and how much you weigh and what your eating habits are, how much you exercise, those types of things. And an online energy audit for your house would be similar. You would get, you know, what year was it built, how many square feet is it, what kind of windows do you have Energy Star appliances, what are your temperature ranges you like, et cetera, et cetera. But key to those is that nobody actually looks at your house and nobody actually looks at your body. And so the answers you get out of that are necessarily kind of vague. You can't really take any action off of it. You're going to find out things like, you know, maybe you should lose a few pounds, or I suggest you eat some more vegetables. That's the type of thing. Or on the home side, it may be, you know, you may need more insulation in your attic. But you can't really do anything with that. So that's the first kind of level. I've been trying to think if there's a medical analogy for the do-it-yourself audit. I'm not sure there is. I don't know anybody that kind of does their own physical exam or writes prescriptions for themselves. But if you have any ideas, I can weave that in maybe the next time into the program. But certainly the next step is clear. If we're relatively healthy, we still want to go to the doctor for a physical. And in that one, you're going to a trained professional, but they're a generalist. So you're going to go to a general practitioner or a family doctor, and they're going to do a range of tests and observations of you that are pretty standardized. They kind of do the same thing for every person that comes in. They're going to check your blood pressure and your pulse. They're going to weigh you, and they may draw some blood and check your cholesterol and things like that. It can be quite comprehensive, but it's still standardized. And our efficiency audit that you're going to hear about from John Fassler tonight really targets that. It's quite comprehensive, includes things like blower door tests, infrared scans, combustion safety testing, visual inspections, but it's pretty standardized. And you're going to get some recommendations out of that you can actually take actions on. You can take the information to a contractor and say, this is what I learned, help me fix this problem. So that's kind of the general practitioner family practice model of an energy audit, efficiency audit. Now it's possible during that they might find that things aren't going so well. You get the oh no from Mr. Bill. Anybody remember Mr. Bill? Okay, lots of people remember Mr. Bill. And in that case, what are you going to do? You're going to go see a specialist. You know, if your cholesterol's high, or maybe there's some other issues, your doctor's going to say, you know, you really need to go see a cardiologist, because they're going to do some more tests to find out what's really the problem that needs to be addressed. We have the same thing with houses. So you can come to our Efficiency Plus audit, which you'll hear about in the second half of the program, which kind of includes all the standard tests, but it's focused on diagnostics. So you may come to that from doing the standard audit and you find out, you know, there's really some problems here that we need to do some more investigation to find out what's going on. Or it might be like you have a broken arm, you're not going to go to the general practitioner, you're going to go straight to the specialist to set the arm. You know, there may be an issue in your house. The most classic is the room that's too cold in the winter and too hot in the summer. Well, that might be an airflow problem, it might be an insulation problem, it might be something else. And just knowing that it's a problem isn't enough to fix it. You need to do some more tests and diagnostics. So we'll be learning about these different levels tonight and different options that we're offering now. So what is the home efficiency program? The main components of it are these low-cost energy and water audits. That's the first step. Second is you're going to get home-specific recommendations out of this audit that you can take to the next piece, which is we're putting together participating contractor lists. These are contractors who have agreed to work to a set of standards that we're defining for doing things like insulation, air sealing, furnaces, air conditioners, water heaters, et cetera, that are working to a best practices standard. By doing that, you qualify for rebates. We also have rebates in the package. So it kind of fits together very nicely. And we're also available as kind of support and coaching for all of our customers to get through this process. It's not easy sometimes to do some of these fixes to improve the efficiency in your home. There's a lot of options and it can be complex. So we're trying to make it as simple as possible and still make sure you're getting really what you need. So the audits, I've mentioned two different types. We have the efficiency audit, which we'll hear about first. That's our standard general practitioner type of audit. It costs you $60. It's about a $300 value of work. It's quite comprehensive and detailed, as you'll see. The second one is the Efficiency Audit Plus, which adds the diagnostic component to it. That is going to cost customers $150. It's about a $600 value. Again, we're really trying to get a lot of momentum in our community for improving efficiency. Audits don't save any energy. They might change your habits. You might learn a little bit. It helps you save a little bit. But just an audit isn't what we're after. We're after getting completed projects here. So to that end, we are defining these participating contractor lists. So along with your audit report, you're going to get a list of contractors. Here's who you can call to get multiple bids. And they're all going to be bidding the same types of jobs, same type of project, because we've defined the installation standards. And here's the rebates that you're going to qualify for there. I'm not going to talk in detail about our evaluation step. We've put a lot of checks in the system, in the training component, in quality assurance, and quality control, to make sure that we're getting the type of level of projects that we expect, the quality we expect, and therefore we'll get the energy savings we also expect out of this. Ultimately, we're after homes that work, they're comfortable, they're healthy inside, and they save energy for you as the individual customer. It also helps our community reach the goals we have for efficiency. So kind of our plan for tonight, we're going to hear about the efficiency audit in some detail from John Fassler from Energy Logic. I'll introduce him momentarily. And then Jeff Grazier from JKG Consulting is going to go into the diagnostic piece, explain what's involved in that. Tonight we're really focusing on this discovery phase. How do we learn what our house needs, where the opportunities are? The next program, coming on March 10th, is completely focused on what we do. How do we fix those? How do we get contractors? How do we figure out the scope? What kind of rebates are available? So we're really going to get into those types of questions in the next program along the way. So with that, we'll bring John Fassler over. John works for a company called Energy Logic. They're based in Berthoud, but serve quite a broad area, and we're very fortunate to have them. They, of course, do energy audit services as they do for our program. They're also very involved in the home energy rating and training of home energy raters nationwide, really.
I'm John Fassler with Energy Logic, doing these audits, and I'm going to go through the process and what I do in a typical audit, what this audit is all about. So Just as far as an overview, what I do for an audit, if you call me to come into your house to do an audit, you call the city and they send me over to do it. We're going to come in, I'm going to look at your house from a building science perspective. And that means that we're going to take measurements, we're going to do it in a way that we're not guessing as far as what might be important. Everybody that does these audits is very well trained in it, and so we're not going to give recommendations that are going to be putting your house at risk for things, health and safety risks, carbon monoxide problems, things like that we're going to pay attention to that can be problems when you make improvements to a house, especially energy improvements. So the first place I start with this is I look at utility bills. Utility bills give me a big clue as to what's going on in the house. I go through the size of the home, the age of the home, and how many occupants. Sometimes I don't know how many occupants until I get there, but a lot of times I can tell that from the utility bills too. So this is before I get to your house. I sit down, I look at it, study it. Then when I get to your house, I actually know what to look for. It gives me a lot of clues. At that point then, I'll get to your house and sit down with you and just talk about what is going on in your house. Sometimes people have rooms that are uncomfortable, just a lot of different small questions there. Then we'll go through a complete visual inspection of the home, looking at everything, do a blower door test, infrared scan, combustion safety testing. I'll talk to you about what the safety issues might be, and then later on you'll get the report from that. So I'll go through these in a little bit more detail now. When I talk about a utility bill analysis, this is an example of a high-use electricity bill. As you can see here, we've got a usage here of 9,000 kilowatt hours per person per year. Now to me, to you, that probably means nothing. And I guess where I'm going with that is I know that the range now that I've seen is 1,000 to 11,000. Based on that, then I know that I'm going into this house. There's a real high electricity usage, so that's what I'm going to be concentrating on in the audit. A lot of looking at where is that electricity usage. I try not to go in with a preconceived notion, but I can usually guess that there's probably a hot tub involved here. The next thing then, here's an example of a very low usage. We've got 4 people in a household, 935 kilowatt hours per person per year. Below, that's the 1,000 is actually a rounding, so we've actually seen this, and this person, it doesn't make a lot of sense to try to figure out where they're using their electricity. We kind of know right away that they're conserving very well, and so then we can look more at a thermal boundary on something like that, on a house like this. As we go through gas usage here, for gas usage, rather than looking at how many people might live in a house, I'll concentrate a lot more on the square footage of the house, and knowing that this one, we're looking at nearly 70,000 BTUs per square foot per year. That's on the higher range. That's the highest I've seen so far. I'm sure there are higher out there, so it's yet to be seen if that's the high mark, and we're not challenging you to get to that, so don't take that as a challenge necessarily. So at this point then, I'm going to be looking for, where is that break in that thermal boundary? Where's all the heat going? Why is it taking so much to heat that house? Then we go to a low usage here. We've got a 3,400 square foot house, 20,500 BTUs per square foot per year. This house, it must be pretty tight. The thermostat is probably being kept at a fairly low level, so we won't worry too much about trying to figure out where the heat's going in a house like this. And for water use too, we've got some really easy metrics to figure out what's going on in this house. Is it a place where we need to look at water conservation? The average water use for indoor use is 60 gallons per person per day in Fort Collins. We take the winter quarter average when you're typically not watering any landscaping, and that gives us what your usage is. Take how many people are in the house, and we can see very easily. This one was at 61, a little over the average, so there's some opportunities to save some water in a house like this. We look real closely at that peak, And I know that 26,000 gallons is not seen very often. I look at anything over 20,000 or so, that there's probably an opportunity to save some water on landscaping issues. So here's just an example of a nice low, stays below 14,000 in the peak, 25 gallons per person per day. I was hoping to look a little closer at that one because that may be a mistake. That's an awfully low usage, but it is possible, I believe. So after doing this utility bill analysis, I'll go through the interview with the homeowner. This is where I find out what their priorities are, why they're doing this audit. What I've heard from a lot of people is they've gotten their report from the city of Fort Collins. And how many people have gotten their report from the city telling them how they compare to their neighbors? This seems to be a great motivator for people to save some electricity and to have an audit and see where their energy is going. We'll talk to people about comfort issues in their home, how many people are there, whether they've done additions, things like that. Anyway, it's really just more data gathering, getting as much information as I can before I go then and start looking around the house. I can learn a lot in that little bit of an interview that may save me some steps along the way as far as doing the inspection on the house is concerned. So then I'll go to the visual inspection on the house. I'll walk around the whole exterior of the house. Here's where you see things like architectural details. After you've done enough audits, you know exactly where the problems are likely to be. So you're looking at all those things. You're making sure that things are vented, that bath fans, exhaust fans, things like that, looking for vents, looking for penetrations in the house, looking for crawl space vents. All these things come into play when I then get inside the house so that I know what's going on outside the house, and it all comes together at that point. I'll go through the attic. How many people have been in their attics? Good, a good number. Anyway, if you haven't, and even if you have, I'm happy to go up there and crawl around and look at some very unpleasant places, really. It's a place where you definitely want a dust mask. I see a lot of things in attics, a lot of things that need to be fixed and that are the causes of a lot of energy waste. So it's a very valuable place to be to figure out exactly what your house is doing, or why your house might be using a lot of energy. So it's something that I think a lot of people will miss this step and not really look at that attic. It's easy, you see your windows every day or things like that, so it's easy to think maybe that window is the problem. Look in the attic first. This is my strong recommendation there. Crawl spaces are also potential very huge problems. Many older crawl spaces are still ventilated and they're not insulated well from the house. They're not separated from the house. It's a cold space underneath. Huge problems for comfort and a huge place for heat to escape. I also look real closely at the mechanical room, see what's going on with the furnace, the water heater, boilers, whatever might be down there. Then I go through and set up the blower door. I've brought a blower door frame. Blower door, it consists of the frame and a fan. This frame sits in the door, probably your front door. Set the fan up. This fan exhausts air from your home, and we create a pressure difference from your home to the outside. So by doing that, I can quantify how leaky is your house. We know if your house has a lot of holes in it, then air is going to be flowing through this fan at a very high rate, and we've got a gauge that then we can measure that rate. So it quantifies that, lets us know exactly how many opportunities, how leaky is this home. If there's a big hole in the side of it, of course, we can plug up that hole. Something that has been found on an attic inspection, visual inspection. This area here is drywall for your ceiling. We're looking at it from the top, from the attic. As you can see, there's very little insulation sitting up there. Then we go to the infrared picture, and this is where we see effects of that. If you look at this, you've got the temperatures. When you look at an infrared picture like this, you can see that the red is at 66, and the coldest is at 56. So this blue area is 10 degrees colder than any of the insulated areas. So it gives you a real graphic representation of exactly the effects of insulation or no insulation. This is what we get out of the blower door. Gives us clues, and the IR. Lets us know what we haven't been able to see possibly on the visual inspection. When we do the blower door, we come up with a number called ACH 50. This is a number that means nothing to most of us. But anyway, what we see is a number from, on the audits we've done so far in Fort Collins, we've seen numbers from 3 to 11 on air changes at 50. These are air changes per hour at this pressure difference. So if I go into a house and I do the blower door and I see we've got 3 air changes per hour at 50 pascals, I know that houses really don't get much tighter than that. Not most houses. There are a few. So I don't really need to look for where is the big hole in the house. But we get 5 and above. That's where that visual inspection, I know that I've got to be looking for that. I've got to find that. I'll go to a combustion safety check after I've done this blower door. And this is a part of the audit that I really commend the City of Fort Collins for pushing and making sure that we're doing this. Combustion safety is something that I think gets missed in a lot of audits. We want to make sure that as we improve houses, that we are making them safe. We're not creating a situation that could be dangerous. And basically what we're checking for is the risk of carbon monoxide from any combustion appliances in your home. Water heaters, this is a good example of a water heater that really has a lot of potential to leak carbon monoxide into your home when it's in operation. And the thing that's going on here is the flue is practically horizontal and it runs for a long length. Water heaters, in order to exhaust carbon monoxide from your home, work a lot like a fireplace, where that flue has to get hot and it has to get the carbon monoxide out. The fact that flue has heated up is a lot of the reason that can get that carbon monoxide out. So there are a lot of factors that influence whether carbon monoxide will get out of your house in an effective manner. One of those is the pressure also in the room where your appliances are located. What we're looking at there is when exhaust fans go on in a home, it depressurizes the home, and that can bring combustion gases back into your house, specifically carbon monoxide. So we test at worst case. We go in and we say, okay, if we get this house to the worst possible case it could be, is there a risk of carbon monoxide coming into the house? A lot of houses pass at that point. It's fine. Then we can stop there as far as looking at whether there's a big risk of carbon monoxide poisoning in your house. But then sometimes they'll fail, and we'll say, okay, that's worst case. What about natural conditions? Go to natural conditions, and hopefully they'll pass at natural conditions, but some do not. So the bottom line is we're trying to make sure that anything we do will assure that your house is not at risk of carbon monoxide poisoning, and especially low levels of carbon monoxide can be bad. So, any carbon monoxide possibilities, we want to know about it and be able to inform you of those possibilities. The other thing we're going to do along with this audit, and this is very valuable, this is a lot of just testing, is we check the heat rise on your furnace. If that heat rise is high, heat rise is the difference in temperature from the air before it goes through your furnace and then after it gets through your furnace. There are numbers, specifications that manufacturers call out for that. We make sure that you are within that spec. We let you know if it's not. External static pressure. This is the pressure that there are pressures on each side of your furnace where it's coming out and going in. You don't need to get too excited about what all that is, but we check it. If it's high, we inform you and let you know. A lot of these, I'm doing the testing, and JKG will talk about this. Jeff Grazier with JKG will talk about this a little bit more later, about diagnosing these problems when we do find them. The other thing we check is your fan motor on your furnace. A lot of these older fan motors take a lot of wattage to run, and that can be a source of a lot of electricity usage, depending on how much you run your furnace fan. Along with this audit then, the other things we're doing is checking gallons per flush on toilets, gallons per minute on showers. We go through and measure those. This is the fancy, sophisticated tool for that. This and a stopwatch, see how long it takes to fill it up. Looking around for plug loads. This is different, a lot of entertainment centers are probably one of the biggest ones there, where TVs, VCRs, cable boxes, all of that kind of thing. It can be a major use of electricity. And then refrigerators. It seems very typical to replace a refrigerator, put the old one in the garage, plug it in, and see how many kilowatt hours you can add up, I guess. Usually that's where the beer is, I think. Anyway, the older they are and the more they are, you can count on a lot of electricity usage in that when you see those. What I've found in these audits, and this is kind of the fun part, what accounts for a lot of energy use. And to me, this has been one of my biggest surprises, is to see a lot of hot tubs, electrically powered, 104-degree water. It looks like you're kind of putting a big pot of water outside, boiling it, wondering where the energy's going, I guess. Anyway, these are not well sealed. I'm not a big fan of hot tubs, and now that I've seen the quantifiable numbers of what they use, I guess, I hope there are solutions out there for this. There does seem to be a pretty big disconnect here between energy usage and the way current hot tubs are manufactured. The famous knee wall. This is a term we use in construction to make sure that nobody else knows what we're doing, I guess. I have no idea why it's called a knee wall, but that's what it is. This is an exposed wall in an attic. The faulty thing that you're seeing here is that you can actually see the insulation. Fiberglass insulation with no air barrier on it, it really becomes a good filter. It'll filter air, it'll let air through, but as far as an insulator, not great. It's doing a little something, but just not nearly what it could be doing. These code has finally addressed these, and we see very little new construction that actually has this defect. But in any house that's over 2 years old, 2 or 3 years old, there's almost a guarantee that you could find some of it. So a very easy thing to fix too. Putting either plywood over it or spraying foam over it, you can block off the air and keep the air from transferring through this and make it an actual insulated wall. This is my fan to nowhere picture. This was the biggest wattage fan that I'd seen, a radon type fan. They had it placed kind of in front of a crawl space vent. You know, the air doesn't really act that way. It's not going to go out that vent just because you put that there. This fan was going at 240 watts. I was very surprised to find that somebody could find that type of a fan that took that much in the way of wattage. So luckily the homeowner had disconnected it because it made a lot of noise. These are the types of things, these are health and safety issues that we find a lot. This is an exhaust fan over a range. It should be vented to the outside, but somehow, some way, over the years, it's not connected anymore. So anything that is supposed to be being vented through that pipe is not, it's just going into the attic. The biggest risk here really is moisture. It's going to create a moisture source right on top of the insulation. And this was a fun one. Somebody had heated their garage years ago, but at some point had decided to disconnect it. Well, and it's hard to tell here, but the end of the ductwork then was then just left open. So we had heat just going into the attic. Attics are usually pretty well heated up on warm days. Even during the winter, they get a little warm if you've got some good sunshine. So they don't really need that. A great find, because this is a place where something like this is very easy to fix. Disconnect that heat duct, cap it off, make sure that none of that heat is going into the attic anymore. And this is the one I'm always looking for, the hole in the attic. This one I could see This was a single-story house, but I could see a broom in the basement through this. This was a very high opportunity, I guess you'd call it, a hole in the attic that needs to be plugged up. A good example of the time not to replace windows, or a time not to worry so much about your furnace just yet. If you've got this much heat just going through a big hole in the attic, a more efficient furnace may save you a little bit of money, but really, you know, it's much more cost effective to plug the hole and stop the heat from leaving the house. So that is what I do with these audits. I can take a couple of quick questions if we have them. We do audits year-round. We do most of the audits in the wintertime because that's when we have the most demand. Now, there are days when the infrared camera is not as useful, but that is actually kind of rare. Most of your problems are ceiling problems that you're going to find with an infrared camera. And that is, the infrared camera is depending on a temperature differential. And so you're going to have a 120-degree attic, very hot attic, so the infrared camera can still show you a lot. It's going to show you heat at that point rather than cold, but that's the place that needs to be fixed. So many of the processes are very much the same in the summertime as wintertime.
We've been contracted by the City of Fort Collins to provide the Efficiency Audit Plus. So you've heard a little bit about that in the first section, so we'll go on into that here. And we'll talk about what is the Plus Audit, and the Plus Audit does diagnostics, a little bit more in-depth diagnostics. So why do I want these diagnostics? Different categories of diagnostics, and what do some of these diagnostics look like, and then we're just going to go in and step through some examples so you get some specific examples with numbers behind them. When you start doing diagnostics, we start putting more numbers, more tangible behind it, so you can balance that against your budget. Efficiency Audit Plus, that starts out with an efficiency audit, basically what John has talked to you about the last half hour. We're going to talk to you, do a little bit of interviewing for the homeowner to see what your concerns are with your house as far as efficiency, comfort, that type of thing, so that we customize the diagnostics to your specific situation. Again, those diagnostics are customized, and then coming wrapping it back around, we go into your house with our diagnostics planned, because we've talked to you, we've seen your utility bills. We need to do those diagnostics to basically prove our assumptions. Is this what's actually happening in this house, or is it not what's happening, before we make a recommendation on the fix. So, again, taking the data and going to where the data leads to drive the fix. Kind of the flow of the audit, customer input, we've just talked about that briefly. Again, it's 20 minutes on the telephone usually, kind of going through the steps of the house. We hope to get that down to 15, but right now it's running about 20 minutes. The basic inspection and testing, that's your efficiency audit. That's what you've seen just over the last half hour. And then we're going to take and do a couple of in-depth diagnostic testing in that. We do the analysis and then come up with recommendations in your report and deliver that report to you. So why do I want to do diagnostics? Why do I want to go to this extra step of doing the plus? You've already had a contractor out in the house, or a couple contractors, trying to fix a problem that you have, whether it's high energy bills or comfort problems. I can't read when I'm in this room, it's too cold, or we can't sleep at night, it's too hot upstairs, whatever it is. That helps us know where to go and where to start looking when we do these detailed diagnostics. If you know already that your house has a complex issue, basically this house is a system. You've got one system in the house affecting another system. Indeed, that is addressed basically in the efficiency audit, and we just go definitely into more detail on that in the plus audit. Things that you can't see with a visual inspection, things that need to be measured. And one of the things we do is a lot of comfort and efficiency in a house is determined by air movement. Air movement is something that basically you don't see very often. I mean, there's some mechanisms we can use. We can generate smoke to check air movement. But just as an example, if you've got a piece of of paper. I've got just scrap paper here, and one that you want to give up at least a square inch of. So if you take that square inch, now this needs to be 27-pound paper, and I think it's only 24, so we're a little bit off here. But you put that on your hand like that, and now if you feel that, or at least if you're young, I think you probably still feel that, that's 1 Pascal if that were evenly distributed on your hand. That's 1 Pascal of pressure. Now that doesn't do a lot for my hand, but that is certainly enough to move air, and enough to move a lot of air. If you've got 3 of these stacked on top of each other, you're getting into, you may have a problem with your water heater. If you've got 5 of them stacked on top of each other, you probably have a problem if you have that open combustion water heater. John talked about the combustion safety test. How does your water heater work? You know, you burn the natural gas in that bottom of that water heater. That air in those combustion byproducts are warm. We know that hot air rises. And so that hot air rises and rises up and out the flue. But if there's a negative pressure in that area around that water heater that's over 5 Pascal, 3, depends on the flue pipe slope, other issues, that can cause those combustion byproducts to spill in your house. So that's why we're using some micromanometers, basically a sensitive pressure gauge to check things like that we can't see. And finally, we want to make an informed decision on what to fix, in what order to fix, what to fix first, what to fix next. These things are interrelated, certainly. You know, you can put a new furnace in your house, or you can fix the building shell. You can, maybe there's some wall insulation that's not working correctly. Maybe there's air leakage. By the time you get done, if you fix that, you may be able to cut that furnace size down 70%, sometimes even 50%, because a lot of times the furnaces are oversized anyway. That could save you some money. The tools we're going to use in the Plus audit, you've seen some of these in the efficiency audit. The upper left is the blower door. The all-knower there, that's just a flow hood. That measures airflow. You just put it over a supply register, return grill, something like that. You're going to measure some airflow. In the center there, that's that micromanometer. Again, measures very small pressures. Thermal imager, you've got the combustible gas detector. That picks up gas leaks, and it'll pick them up before you typically smell them with your nose. Down in the bottom, you've got a combustion gas analyzer. We're going to use that to check how well the furnace, the water heater, if you've got a gas oven. So the gas appliances, how well are they burning? Is the fuel-air mixture correct? Do they have enough makeup air coming in, that type of thing? Lower right is a flow plate. That's just a device that we can use to get you the CFM, basically how many CFM is going through a furnace or an air conditioner on the indoor side. Allows you to go on to the engineering step, the design for the HVAC guy, to say, you know, this is how big my furnace is, this is how big my ductwork is. Let's size the new furnace, the new air conditioner to match my system. Categories of diagnostics. Again, do we need to address a comfort issue for you? Is that high priority? Electric loads, are we looking at high electric bills? Are we looking at high gas bills? Water usage in the winter, that type of thing. Indoor air quality, again, looking at carbon monoxide, looking at air changes in the house. Are we ventilating the house? Also, do we have sources of pollution stored in the house that are outgassing, causing some indoor air quality issues? Next slide, similar to the other one, but just, you know, what are the diagnostics? This is getting a little bit more detailed. What are the diagnostics? Are they? You know, air conditioning, we'll just kind of go down through. Infiltration, well, what's that? Some of the guys in the industry would know that. That's air leakage, the blower door test. That's some other things on there. We've got some other examples of these coming up. So we can get on with our examples. And this is a basic one. The efficiency audit should probably pick up this too, but these keep popping up whenever you're looking the other way. This is a building durability issue. You may not be able to see it real good in that upper corner, but if you look at the lower, there's a bath fan. And I know you can't see it, but right there is where that bath fan vents. It stops right underneath this roof deck. Okay, that should be vented outside. This is the master bathroom. At least 1 shower a day. This is probably 2 showers a day. This attic did not have enough venting, or not that would have solved the problem, but it was low on venting for normal attics. So what you've got is you've got stuff growing on the underside of the roof deck. This is, you know, about a ½ inch thick up here. This is the siding that's right over here next to this wall, And you see how we're in the attic looking down, and you're seeing air. That siding is bowed out. That siding has just been, the moisture content of that siding has just been going up over the years, and freeze-thaw cycle also happening on that. Just a basic issue, like I said, efficiency audit and efficiency audit plus should catch things like this. Let's look at a customer. This customer had twice the electrical usage from average. So this should be an easy win to get them back down to average, maybe even below. We did a base load to their house. And basically what that means is we had them turn off the lights and turn the appliances, appliances on standby. What I mean by that is you don't turn a refrigerator off. It's just kind of sitting there and the compressor's not running. That's on standby. Your furnace is on standby a lot of the time, waiting for the thermostat to call to kick it on. So we measured 960 watts for the whole house at that point, right? We've turned everything off and the house is using 960 watts. Right there, that 960 watts puts them an average Fort Collins customer. That means they can't turn on a television, their furnace can't run, they can't turn the stove on, or they're above average. So we knew something was going on. So we just walked around the house quickly with them, disconnected, basically it was the entertainment center. We just pulled the plug on that, and he had two computers. One was running and one was on standby, so we shut those down. That took him down to 508 watts. So at least he has a fighting chance here. It's 508 watts 24/7, and then spikes of use. He said, well, where's this other 508 watts? So we just went in further on this diagnostic. We just started unplugging stuff. You can read coffee maker, microwave, lights under the counter, the transformer, these sintered plug-ins that were in the wall outlets. I mean, multiple televisions in multiple rooms. He said, well, let's unplug the sprinkler system since it was November, I think. So we pulled that. Anyway, basically all that was left on was the appliances on standby. Furnace was ready to go, the refrigerator was ready to go, telephone answering system, right? Garage door still using electricity. 46 watts. What a difference. I mean, they went from 960 watts to 46 watts. So I mean, if they run the house in this configuration and switch on things when they need it with a power strip or maybe one of the smart power strips that were in the giveaway, I mean, they're well on track to be half of an average customer and maybe even less than that. Another diagnostic we can do, rated versus installed performance. So basically, we've got different systems in our house, and well, I don't know, do we think? I mean, we buy a radio or television, and we expect it to work. We plug it in, and we expect it to work as advertised. And we carry that over into our houses a lot of time. We install an air conditioner, we install insulation, and we expect it to work as advertised. Sometimes they do, and sometimes they don't. Well, let's just talk about one, an air conditioner. We see 11-SEER air conditioners all the time. We'll test it. They come out, they're running at about 7. What's going on here? And even below that, they're running at 7, and they're delivering about 4 energy ratio, ER, which is part of that SEER, of cooling. That other 3 is going to dehumidification, right? In Colorado, we don't need much dehumidification. There's a few days of the summer that we do, but most of the time we don't. So my 11 is actually delivering 4 of cooling. It's a big issue in the northern Colorado area. A lot of it has to do with sizing the ductwork for the air conditioner. Typically, ductwork ends up too small, and then the refrigerant charge gets adjusted to make that system even work. So that's not too uncommon. Insulation, John showed you a picture of a knee wall in an attic, that insulation that had no backing on it. That's going to have performance problems. That was probably an R13 rated insulation, and it might be performing at half of that. Here's another diagnostic. This was a quick one we did for infiltration. The infiltration, again, that's that blower door test. So you're depressurizing the house, concentrating all the leaks, and so you get an idea of how leaky, how many holes do I have in my house? Well, with this customer, it turned out they had a pet door. They had taken a sliding glass door, opened it about a foot, and put a pet door in the rest of that section. That right there was 20% of their air leakage. They've got the information now, and they can make the decision what that pet door or that installation of that pet door was worth. There's other pet doors that can be installed in a wall and have a magnetic type closing, and then you wouldn't have the meeting rail problem where the sliding glass door was actually leaking more than the pet door. This house, there was attic hatch, pull-down type attic hatch, no weather stripping or around that. And then duct leakage up there, that was a return duct leakage of 3%. Not a huge number as far as infiltration, but it was one concentrated place that can be fixed. That also can lead to other problems in the sense that when that ductwork is pulling, gets housed as a system, right? You've got one system messing with another system. We've got a furnace or an air conditioner coming on, and it's sucking in air from the attic instead of air from inside the house. So in the winter, it's pulling in 30-degree air, whatever that attic is. In the summer, it's pulling in 110-degree air. So that knocks down the efficiency on the whole house. This one's a little bit more technical. Actually, it has to do with that example I just talked about. Let's say on the efficiency audit or plus, we measure your blower door number is 2711 CFM at 50 Pascal. We did a test on this house, and we turned the furnace on. So now get rid of the blower door. We're not thinking about that anymore. We just turned the furnace on. When we turned the furnace on, the upstairs was pressurized at 4.3 Pascal. The basement was depressurized at 4.3 Pascal. So remember we talked about one piece of paper moving air, so now we've got 4 pieces of paper moving air. And so what this furnace was doing, every time it came on, it was sucking in outside air through the cracks in the basement and exhausting this outside air out the cracks to the attic or out the windows. It was 81%, it was running 81% efficient, so the loss was 19%. Basically that furnace was delivering 4/5 of what it should be delivering. 1/5 of that energy of that furnace was going right outside. So 20% loss from that. The problem was a leaky return system and an imbalance in the sense that when you supply a room with air, you're positively pressurizing that room, you need to provide a path for that air to go back to the furnace. And they weren't in balance. We had the returns pulling air out of the basement, sucking the basement negative, and the supplies positively pressurizing the upstairs. And one duct system change, one afternoon, took care of this problem. I mean, that's 20% on their gas bill, basically. At least on the gas bill, the heating portion, not the hot water heating portion. John gave you a picture like this. This was kind of a trivia. How much difference, this is a pull-down attic hatch, and it doesn't have insulation on it, so it's 1/2-inch plywood. Now let's give it the benefit of the doubt and say it's R1. It's probably a little bit less than that. But let's say the ceiling all around it is running at R38. That's a code insulation value. Let's say it was perfectly installed and there weren't any deficiencies, so R38 for the whole roof and R1 for that attic hatch. Okay, so 2 foot by 5 foot, 10 square feet attic hatch, and 1,500 square foot attic. So any guesses on what that looks like from the energy perspective if we're looking at the conduction losses from the house to the attic? Less than 1% of the square foot is in that spot. But remember, the rest of the attic is insulated 38 times better than that one spot. Well, if you work out the math, it comes out about 20%. That one spot, 10 square feet, is worth 380 square feet if you're looking from the energy perspective. So my whole attic went from 1,500 square feet to 1,880 square feet. Your attic basically just grew that size as far as energy was concerned. Insulation works, the best way to apply it is evenly across the whole house. Top, bottom, sides, that gets you the best performance. I mean, that roof could have been R100, but if you still left that gap, you still had some good size heat loss. Thermal boundary misalignment. Okay, so what is a thermal boundary? A thermal boundary, we talk about that. We talk about the building shell, so that's what separates you from the outside, separates your house from the outside, the contents. To make that thermal boundary work, we need an air barrier and insulation, and they need to be coincident, right next to each other. So this is common, what we call thermal bypass in the industry, is when we get this misalignment. We've got an air barrier here and the insulation over here. What that allows is the outside air to move in between here. So typical, floor over garage, was it inside or outside? But we looked at this house and got up in that room and we could probe down and we could tell that the insulation was sitting on top of the garage ceiling drywall. So that's our air barrier. That's our thermal boundary, the garage ceiling drywall with that insulation over it. So there was about this much gap between that insulation and the bottom of the floor, the subfloor to the bedrooms. And that space measured 41% outside. So we had outside air moving underneath this bedroom, rendering the insulation, I don't want to say useless, but really useless. The customers had comfort problems in that room. The room was, I mean, it was 40 degrees on the outside. You know, it was in the morning when we did that audit. And we were looking at 8 degrees temperature difference between those rooms and the other rooms in the house. When the fix was done, which kind of was the proof in the pudding, I guess, that those rooms warmed right back up to the house. And again, just the thermal boundary misalignment. This is, well, the same issue. In the floor, you have real trouble seeing it. In a wall like this, this is easy to see. This is a knee wall example. John gave you the knee wall from the back side. This one actually looked amazing from the back side. They had R19, which is 5.5-inch thick blankets. Okay, so not the bats. They're 4-foot blankets rolled across this. Just really nice from the attic. This looked great. But that's the way it looked, and that's the way it performed thermally. What's going on? Again, you've got that nice insulation, but the air is moving behind the insulation between the drywall and the insulation. Was the insulation there? Yes, the insulation was there. Did the insulation work? Well, no, it didn't. I know this is kind of engineering language, so we'll try to work through it here. The heating plant, cooling plant. Well, that's your air conditioner, that's your furnace, or that's your boiler if you've got a boiler. The distribution system, that's your, typically that's your ductwork if you have a furnace, forced air system. If you have a hydronic system, if you had a boiler, that would just be the pipes and the convectors, that type of thing. And the heating and cooling load. So that's how much heat this building is losing in the winter. So that means that's the same amount of heat that the furnace has to put in if it's going to hold a steady temperature. All three of these things need to work efficiently, need to be sized together. If you've got a furnace that's larger than a ductwork, there's going to be inefficiencies and there's going to be noise on that furnace, possibly, or it's just not going to work right. John talked about, if you remember, he said we measure external static pressure and heat rise. Those are two indications. Does the duct system match the furnace? And certainly the other on there is the house itself. What's the heat load? So if my ductwork is smaller than my furnace, what are my choices? If we want to get this system matched up, well, we need to ask, what's the heat load on the house? Is the furnace bigger than the house, or is the furnace just right? If the furnace is bigger than the house, again, we're going to size the furnace down so the furnace matches the ductwork matches the house. Problem solved. If the furnace is the right size for the house, well, then we've got to bring the ductwork up in size to make that work efficiently. Not a real easy retrofit in a lot of situations. Unfinished basements, crawl spaces, it's no big deal. In a finished basement, yeah, it can be a big deal. Although there's things you can do a lot of times right there in the mechanical room where they have 90-degree elbows and things like that that add a lot of resistance in a ductwork. Those can be taken out, put radius elbows in, put turning vanes in, things like that, that you can solve that. You can either solve it or at least move it real close to a resolution. Again, I'm Jeff with JKG. Thanks for your attention. And I think John said he was going to come back up and we were going to do some questions. So thank you, guys. We're doing, in the past, typically we've been doing about an audit a week. With this program, that's what our initial idea was. That's turned out with the response that we've been getting that's not near enough. And so we're going to be stepping up to 2 audits a week here pretty soon, and it's possible that could go more. Think of an electronic appliance you buy. Think of a car you buy these days. I mean, they're engineered, they're working out the bugs in the factory. And when you're building a house, it's built on site. It's not built in a factory. So they miss some of that feedback to correct the problems. I would say that we typically find at least one major defect, one thing that can be fixed in a house that makes a significant change. A lot of times we find many more. And let me put that in context too. 100 years ago, where were we? Our bathroom was outside, right? I mean, we had a well that we pumped to get our water. We've moved inside. We now have plumbing inside. In the 60s, we started insulating our houses. Now we're insulating and air sealing our houses and dealing with the indoor air quality issues. In that sense, in the sense that our pollutants we can add more pollutants than the natural infiltration is going to take out. So housing is changing. So even if we were that house that we build today is right on the mark, with technology 10 years from now, we might be saying, well, we could upgrade that.
We do have some builders on the new construction side that are building some houses that are really rooted in the building science and really bringing the entire picture to the table, and generally much better houses than the production houses we've seen over the last many decades.
Mm-hmm. And the answer is no, in the sense that we don't run an energy model on every house. That's an option that we can do. You'd have to substitute one of the diagnostics for that.
The challenge with trying to do return on investment is that for us at the audit phase, we'd have to decide how much it's going to cost you and get into the bidding business, which is not our business. So we're really trying to rely on the contractors that do the work to bring the actual pricing to you that's going to enable you to do that type of calculation. And so the only thing we know for sure is if we started getting into guessing the prices, the only thing we'll know for sure is that we're wrong. And that that's really the contractor's specialty to bring the pricing component in.
The thing I would add on that is when you're in this business a while, you've done the audits, you've done the fixes, you've tested the fixes, you learn quickly what's easy to do and where those paybacks are. John showed you the hole going through. Hello, that's exactly. That's a half hour. It's an hour by the time you put your mask on and get your clothes on and get it fixed and clean up. But yeah, exactly. Something like that is worth, hours of sealing cracks.
Yeah, so what we've done in the audit report is try to put together a report that's going to give you priorities and give you those higher return on investment or easier things to do that are going to pay back the quickest. So the audit report is going to be, you're going to have a list of recommendations, and there'll be high, medium, and low, so that you can very easily see then which you should approach first, or what order you should approach them. Mm-hmm. At Energy Logic, we use rim rate mostly for new construction. We don't really find that it adds a lot of value for existing homes. It may give you a number, but really what you're looking for, I think, is what we're doing in this audit report. You're looking for priorities. So there may be a time when the rim rate or some of the modeling softwares become more valuable, and that is specifically Energy Star mortgages that I've heard a little bit more about lately, where they will do a mortgage or a refinance based on having that rating already done.
And my experience with the modeling software, we've used the RIM design and then also the TREAT program. And one of the best, it's not an energy model, but really you've got an up and running house. If you want to ask the question, how much energy is this house using? We can enter it in a bunch of software, but we can always just step back and look at the energy bills and say, well, it's right here. We know how we've been operating. We know how we've been keeping the thermostat. We know how many showers we take a day. That's the most accurate analysis of that house right there. And in these audits, we're going in and we're finding the holes and the cracks and stuff like that. Those are taken into account in an energy model in an aggregate sort of way. Whereas the audit itself, it's getting right down to the specifics. This is what you need to address.
I think your point is still well taken, though, that we may be able to look at as more financing options become available, what are the requirements that they're going to need to document savings, and how we can align our reporting and programs and services with that, or help them come up with ways that they can understand what the best tools are to use. And some of those discussions are going on an ongoing basis, both locally and statewide, to try to solve some of those issues between different sectors and service providers trying to speak the same language, really. The question was about a instantaneous type of hot water heater, natural gas fired one, I presume?
Yes.
Okay. Anybody want to tackle
Yeah,
that?
I'll take it off the bat and let you go. So, a lot of those, your standard tank type water heater. So those are reheating that water at about 80%. Most of them. There are some real high efficiency units, but they're very pricey. Your tankless, some of the tankless are around 80%. Now there's some that are up in the high 80s and in the 90s. So that's just, exactly. So we're looking at, if you're going high end, you're looking at, let's say, well, and I'm going to back up here, at least let's say a 15% savings. Now there's some losses in that water heater, and they're going to give you an efficiency of 65%. Some of that heat goes up the flue, some of that goes into your house. The jacket losses go into your house. We're heating climates, so some of that's used to heat your house. So you figure the efficiency of your tank water heater is somewhere between that 65 energy factor and that 80% recovery factor. Sorry, I got off on that big long thing. One other point to make is look at your energy bills, do the analysis. How much gas am I using and how much is that costing me to heat the water? And how does that compare to how much gas I'm using to heat the house?
So, there certainly is usually can be an efficiency improvement in your actual water heater unit, as well as not having the standby losses. On the other hand, you could take a 16-hour shower and you'd use more gas than you might with the other one. So don't forget the personal habits in there as well. So.
Yeah. The tankless water heater, we've had one in our house now for 3 years. It did cut our water heating bill in half, but you're talking half of a $20 bill.
Yeah.
So it's typically not a real high payback. The value in a tankless water heater, one of the values to me is that it's usually a sealed combustion unit. That's a very high value, very little risk of carbon monoxide backdrafting. So that was part of the reason that I went that way. I see when I do the audits, I'll go in and look at bills, and sometimes I think, oh, this has got to be a tankless house because they've got 5 or 6 therms being used in the summertime. Mm-hmm. That's usually all water heating, and I'll go in and find that it is a tank type water heater. So I don't know what the secret is, but some people have really lowered their energy use even with a tank type water heater. So that's an ongoing investigation.
Great question. So, as to compare the Excel audits, most of you, I'm sure, are aware that if you're one of our electric customers, but you have natural gas service to your house, you're also an Excel customer. Excel has had an audit program for about a year, maybe a little bit more than that now. We looked at their program and what they've offered, and ours essentially is our efficiency audit, our $60 standardized audit, does more testing than their highest level audit. The one thing that's significant difference is we've added the combustion safety testing on every house where they have atmospherically vented gas appliances. That's a piece that we may be the only utility, perhaps in the country, that's doing that, because we know it's a problem and we're not hiding from it. And frankly, a lot of utilities say, that's kind of too scary to get into health and safety issues, but we're a municipal utility, we serve our community, and we think it's important, so we included that in there. I think that's probably the biggest difference, as well as the cost. So you're going to pay $60 for a more comprehensive audit than a $120 audit from Xcel Energy. That doesn't say anything about that. They've got some very skilled providers and good people doing their audits, but we think they won't be doing too many of them in Fort Collins.
Like I said, John mentioned in the attic, you find all sorts of things up there that need to be fixed in the crawl spaces. And normally we'll put that on the report if we notice it, but we're not, it's a tricky to walk that line of taking the liability for something you know, because if you put it on the report, are we taking the liability for putting it on there accurately and that type of thing? So, but yeah, I certainly at least tell the homeowner what I see and you know, recommend that they get things looked at.
Through our program, basically primarily because it's funded from our ratepayers, are basically funding the program here. You can certainly get similar types of audits at market rates, you know, from either of these providers or others out there in the community that can do this type of audit, but you'd end up more than likely paying, you know, that full cost of the audit, whereas we're subsidizing that for our customers. Now remember, this was just part 1 of this series, so part 2 actually gets into, okay, we found all of these problems, what are we going to do about it? How do you go about fixing that? And through our home efficiency program, we're going to be providing lists of contractors who are specifically trained in the best practices and standards that we've started talking about just a little bit tonight, and we'll go into much more detail there. That will also qualify you for the rebates that are part of this program as well. So that's really where the rubber hits the road, and how do we take care of these issues and get houses that are use less energy, more comfortable, and address any health and safety issues at the same time. Thank you very much.